So now question number 8, it reads as follows. They say to us 8.1, for events A and B, it is given that the probability of A, it's 0.35, and the probability of B, it's 0.4. So 8.1.1, it says to us, 8.1.1, it says to us, calculate probability of A or B if A and B are mutually exclusive. So in order for us to calculate probability of A or B, we know that there is a formula that we use to calculate probability of A or B. So in this case, sorry, a little bit about that guy. So now, to calculate the probability of A or B, the formula that we use is given by, let me write it over here, probability of A or B is equals to probability of A plus probability of B subtract the probability of A and B. This is a formula that we use, but you have to understand that this formula, we use it under different conditions, okay? So now, what are the conditions? It's when you are told that the events are mutually exclusive or they are not mutually exclusive. And then again, for 8.1.2, still they want us to calculate probability of A or B under this condition whereby event A and B are independent. Again, it's either we use this formula under the conditions whereby the events are independent or they are not independent. So let me try to explain 8.1.1 first. What is the condition here? So we use this formula because we're going to use this formula, but how? Let's see. So when probability of A or B is equals to probability of A plus probability of B, subtract probability of B, we use this formula when the events are inclusive. That means when the events are not exclusive, we can use this formula. But when the events are exclusive, we use this formula. Probability of A or B will be equals to probability of A plus probability of B. We do not include intersection. Our intersection here, it is 0. Why? Because the events are mutually exclusive. So that means in this case, when we talk about a Venn diagram, we are talking about the circles that are separated. When the events have separated circles, we say the events are mutually exclusive. Therefore, we use this formula. But when the events has an intersection like this intersection, it is the probability of A and B. So when events are inclusive, so that means or not mutually exclusive, not exclusive. So that means we use this formula whereby we're gonna have to subtract our intersection, which is a certain numerical value. Here our intersection, it is not 0, but here where are exclusive, probability of A and B is actually equals to 0, and therefore we use this formula over there. Okay, so here they want us to calculate probability of A or B. A and B are mutually exclusive. So that means we're going to use the formula that says probability of A plus probability of B, and our probability of A and B, it is 0 because they are mutually exclusive. So we are given probability of A to be 0.35, plus we are also given probability of B to be 0.4. Therefore, what will be the final answer in this case? You're just going to say 0.35 plus 0.4, and then how much do we get? We get 0.75. This is probability of A or B. Now 8.1.2. They want us again to calculate probability of A or B, but under which condition? Whereby A and B as our events are independent. Once more again, when the events are independent events, we say probability of A multiplied by probability of B will be equals to probability of A and B. This is for independent events. But the dependent events, or the events that are not independent, Probability of A multiplied by probability of B is not the same as probability of A and B. Okay, so sorry, for independent event, this is true. For dependent event, this is also true. Here, our product is not equals to the intersection. That's the dependent, and in the, it is true. So here they want us to calculate probability of A or B. So we're going to use this formula, but we need to ask ourselves, am I going to use this formula or this formula? The first thing is, do I have intersection or I do not have intersection? For a fact that they said the events are independent, so that means it is true, you do have intersection. So that means you're going to use this formula above that has intersection. So that means if events are independent in this case, they are also mutually inclusive. They are inclusive, they are not exclusive. So to calculate this, we use this formula again, probability of A plus probability of B, subtract the probability of A and B. So why did I include this? Because for independent events, I know that probability of A times probability of B will give me intersection, which is probability of A and B. So what is the, let's calculate our intersection first. So what is probability of A? The probability of B is given to A is given to be 0.35. What is the probability of B? It is given to be 0.4 is equals to my intersection, which is probability of A and B. And therefore, what will be probability of A and B? Now I find out on my calculator that the probability of A and B, it is given to be 0.35 multiplied by 0.4. How much do I get? Actually, I get 0.14. Now, let me determine what the question wanted me to do. Probability of A or B. So probability of A or B, I'll just say, let me utilize this space over here. Probability of A or B will be equals to, what is probability of A? Probability of A, it's 0.35. What is the probability of B? Probability of B is 0.4. Subtract, what is the probability of A and B? We got that it's 0.14. And therefore, what will be my final answer? Probability of A or B, I'm going to say 0.35 plus 0.4, subtract my answer, which was 0.14. And then I get that my probability will be 0.61. This is how we treat this question over here. Now we jump to question number 8.2. Now, this question is contingency table. It is called contingency table. You see, these questions are different. We started with Venn diagram, tree diagram, and we also did that one, the probability. And therefore, now we are talking about the contingency table. So I really love this question paper because it exposes us to different type of setting of question paper. Ne? So now, let us read this first. They say to us, a survey was conducted among 150 grade 11 learners about the genre of the music that they listen to mostly. The results are shown in the table below. So we can see that we have different genres of music. We have classical, we have pop, we have hip hop. There are 3 of them. And then we have girls and boys who are under these categories. So how many number of girls are in this school? There are 80. How many number of boys are in this school? There are 70. Number of learners in this grade 11 class or grade 11s is 150, which is what we were told. So now, 8.2.1, it says to us, write down the value of K. This is the value of K. What do we mean the value of K? We can see that K, it represents a number of girls who love pop genre. So that means, how are we going to determine K? We can use this row, we can use this column, or we can use this row. But the problem is we do not have total over there. We can determine this total by saying we know that 67 plus 50 will give us 67 plus 50 will give us 150. So that's a longer way to determine it. The easiest way to use is to use this row, because we can see that the total is 80 of the girls. So that means we're gonna say, what is the numerical value of A? To answer 8.2.1, we're gonna say 35 plus 27. It's how much? We're gonna say 35. Okay, let me just do it. 35 plus K plus 27 will give us a total of girls, which is 18. Therefore, from this equation only, we're going to say 35 plus 27, we get 62, and we say 80 subtract 62, we get 18. So that means our value of K will be 18 for 1 mark. (8.2.2), it says to us, if a learner is selected at random from the group, a learner selected at random. You see, this statement itself, it is very important. A learner selected at random, what does that tell us? It does not matter whether you select a boy or you select a girl. So that means, what will be the total number of at which you're going to select out of? You're going to select out of 150, because 150, there's girls and boys. That's the first thing that you need to understand. You need to know how to analyze this. If a learner is selected at random from the group, what is the probability that the learner is a boy and does not listen to pop music? If does not listen to pop music, what does the learner listen? That means it's either the learner listen classical or it listen hip hop. Can you see that? So we want to determine the probability. So for 8.2.2, when we want to determine the probability, we want to determine the probability of choosing a boy who does not listen to pop music. So that means he listens to what? He listens to classical and hip hop and is a boy. So we go to our contingency table, we look for boy. So now these are the boys who listen classical. These are the boys who listen pop. These are the boys who listen hip hop. So we're going to eliminate this. So that means, how many boys who listen anything except pop? It's going to be 32 plus 23. So that means we're going to choose out of 32 plus 23 learners, boys. But how many number of learners are there? There are 150, because remember, where do I get this 150? If a learner is selected at random. So for the fact that the learner is selected at random, meaning it shows that we're going to select out of boys and girls, meaning they are all 150. Okay, I hope that was clear. And therefore, what would be our final answer over here? You're going to say 32 plus 23, it's 55 over 150. 55 divided by 150, we get 11 over 30 to 2 decimal places. Probability will always be less than 1, okay? There is no way that probability will be greater than 1. When you perform your calculation and you find out that your probability is greater than 1, you made a mistake. There is no way your probability will be greater than 1. Probability scale, it ranges from 0 to 100. Sorry, from 0 to 1. 0, it is not certain. 100, it is certain. And then 1, it is certain, which is 100%. 0 is 0%. So you can't get number which is above 1 when you want to calculate probability, okay? So now 8.2.3, it says to us now, are the events being a girl and listening to pop music independent? Show all necessary calculations. Literally, we need to show that are the events independent or not. I say to you, if the events are independent, we said that for independent events, for events to be independent, we know that probability of A multiplied by probability of B will be equals probability of A and B. So now here, because we are dealing with a girl and a boy, a girl and the one who listens to pop. So that means we're gonna talk about the probability of girl, right? We need to know the probability of a girl. Number two, we need to know the probability of listening to pop music. Okay, listening to pop music. So I'll just say, okay, let me write it. Listening to pop music. Ne? We need this probability. And then we're going to calculate this probability. We're also going to calculate this probability. And then again, we need the intersection. I'll show you how to see intersection on the contingency table. Again, we also need probability of a girl and this thing, which is listening to pop music. I'll just write LPM, okay? To summarize things, we need this. So firstly, let us first determine the probability of a girl. So what is the probability of a girl? Remember, are the events being a girl, which is this, and listening to pop music, which is this, independent. We need to do that. So now let us determine the probability of a girl. So how many girls are there? This is what is happening. We have a total number of 80 girls. Okay, so we need the probability of a girl randomly. So probability of girls is going to be 80 divided by 150. We're going to have 80 divided by 150. Now, what is the probability of listening to pop music? So remember, this listening to pop music is not supposed to be a girl only or a boy only. It's listening to pop music. So let's go to pop music. So pop music, it's in this case, it is 15, right? Only pop music, listening to pop music, it is 15. So that means, what is the probability of people who listens pop music? Is 15 out of 150. So you're gonna have 15 out of 150. Can you see that? Now let's talk about the intersection. A girl and listen to pop music. A girl and listen to pop music. So we want a girl and the girl who listens to pop music. Now, what will be the probability of a girl who listens to pop music? So that means in this case, it's
It's a mistake. It's 18, it's 15.
oh, girl, not boys, ne? I can see, man. Why I chose girls, not boys. So that means it's gonna be it's gonna be 18, right? Which is our value of K. So it's gonna be 18 over 150, 100%. It's gonna be girl. I get. Now we need a girl and pop music. Now a girl and pop music. No. It's supposed to be 33. Ne? It's supposed to be, remember, we want listen to pop music. What is pop music? Pop music. I think I made a mistake here. It's 18. Listen to pop music, it's 18. And then what is the probability of girl and listening to pop music? Let me see. This is supposed to be 18. This one here is supposed to be 18. Here we have 18 over 150. Okay. Remember, it's a girl. It's a girl. And then who listens to pop music? So 18 over 15 is supposed to be here. Okay. And therefore, let's determine this one there, listening to pop music. So now listening to pop music is going to be, let me see, it's going to be, it's supposed to be 33. It's going to be, oh, sorry. Yes, this is 18, and therefore here it's gonna be how much. I did my calculations here. I wanna see if I did correct calculations. We said probability of girl and pop music is equals to that. So let me see something. I'm gonna say 80 divided by 150 multiply by let me check something. Multiply by 18 multiplied by 33 over 150, and then we get 44 over 375, which is 0.11, and therefore 18 divided by 150 is going to be 0.12. All right, so now here, this is not 18 over 150. I see where we did a mistake now. This is not going to be that. Remember, we want who listens to pop music, right? This is pop music. The thing is, it's not even there. We need to calculate it. So that means, remember, we said our K is 18, right? And then here we said it is 15. This will be pop, total of pop music. Remember, it is irrespective whether a girl or a boy, because they didn't say girl who listens to pop music, or they didn't say boy who listens to pop music. They said listening to pop music. So that means you're going to take total of number of learners who listen to pop music. So 18 plus 15 on my calculator, 18 plus 15 is going to be 33. So that means here we're going to have 33, you see? So that means let's go then. So listening to pop music is going to be 33 over 150. Okay, so probability of girls, we need girls only. They are all 80 out of 150. And then probability of girl and listening to pop music, we specifically going to our intersection. We're going to girls only and pop, which is the intersection between girls and pop, which is 18. Okay, all right. So now let us determine the probability of girl multiply by the probability of, you know what, I'll just simplify it, listening to pop music. I'll just say it's LPM. Okay, now let us determine the product and see how much we get. So the probability of girls only is going to be 80 over 150, and therefore what will be the probability of LPM, which is listening to pop music only? We said it's going to be 33 over 150, and therefore when we punch this on our calculator to two decimal places, we're going to say 80 divided by 150, okay, multiply by 33 divided by 150, and therefore how much do we get to two decimal places? We get 0.11733333, but to two decimal places is going to be 0.12, okay, the product over here. But then what is the probability of girl and listening to pop music? We said it's 18 over 150. Now, when we punch this on our calculator to convert it into decimal, 18 divided by 150, we get 0.12 of the gap. So this is 0.12. Now we can see that the probability of a girl multiply by probability of listening to pop music, it is actually equals to probability of a girl and listening to pop music. Now, for the fact that this is satisfied, this side of the equation is equals to this side of the equation. That means the events that are said to be, independent. Okay, that means the events are independent. So be careful when you do your contingency table. Okay, so like here you see there was no calculation, so complete before you can even answer. My advice is, before you can even answer all of these questions, complete your contingency table so that you don't get confused. So that means this is what we all needed. Okay, all right, let me